Okay, in this tutorial I'm going to run through basically the history of the atom, so the scientists and the key ideas that led to the development of our model of the atom. Let's start with it. Here's a basic timeline. It's worth noting that the dates aren't necessarily exact, especially the early ones. And also, you don't have to remember, for your test guys, you won't have to remember the dates. You really just need to know the name, the key idea, and maybe how to sketch a quick diagram of that illustrates the model that person proposed. So starting back a long time ago, 400 BC. So, I mean, we're really talking, well over 2,000 years, well before Jesus Christ. We're talking a long time ago. Democritus, a Greek man, essentially came up with the idea that there was some indivisible unit, that the world around us was made out of small parts, and that at some point they got as small as they could possibly get. So if I take an object like a table in front of me and I cut it in half and I cut it in half again and I keep cutting it in half, eventually I get to the core particles that the table was made out of. So he used the word atomos, which is basically Greek for uncuttable, or indivisible, cannot be divided any further. So he basically believed that they were these things called atoms, that they had always existed and would always exist, and couldn't be broken down into smaller pieces, and that atoms had different shapes and sizes. So he was right for the greater part. And it's sort of quite amazing that this was purely philosophy at this stage. It was just thinking, it was just an idea, really. But he had a few funny ideas too. So, for instance, when I say that he believed atoms were different shapes, he, for instance, believed that the atoms in metals like steel were had hooks in their surfaces that would hold them together, and that's what made them so strong. Or that the atoms in salt were sharp and pointed, and that's what gave them that sharp taste with the little points sticking into our tongues. He had some good ideas, but some of them weren't quite correct either. So the key idea here is really just that idea that Democritus came up with the idea that there was sort of a fundamental indivisible unit, an atom that the world around us was made out of. And so to draw this, you really basically just draw a circle. It's just really this initial idea that the world around us is made out of these particles called atoms, and that's really about it. So everything is made up of atoms, indivisible particles separated by empty space. Atomos, that Greek word, uncut, meaning essentially uncuttable. Those are probably the key ideas. So that first line, maybe the word atomos, is what I'd expect you to maybe give in a test, and your diagram just basically a ball or a sphere. So a long time passed. We now fast forward to 1803, and it really is a long time where this theory of an atom didn't develop any further. And then we get to Dalton. So Dalton in 1803. Basically extended our knowledge of atomic theory. So he basically, studying pure substances, revisited this idea, and he came up with the theory that elements are made of extremely small particles called atoms. He believed that these atoms had different shapes and masses, but that they couldn't be subdivided or created or destroyed. And he believed that it's these different types of atoms or elements that would recombine in different combinations to form chemical compounds. And so his study really was based largely just on the quantities of materials and the ratios in which they would combine, and he related that back to the sizes and quantities of the atoms involved in those reactions. And started to see patterns or trends that made him believe that these materials were made out of fundamental units, these atoms, that could combine into different combinations, the things that we call compounds. So again, for this model, the key idea basically here, just I guess the difference between him and Democritus is he actually did experiments. There was evidence for this theory, but again, basically just believing in atoms that varied in size and mass. So different types of atoms that varied in size and mass that made up the world around us. So again, a very simple model that's basically just drawn by a circle, or here I've drawn a few circles that are a slightly different size. And that was basically what Dalton brought to the table. So, fast forwarding a little bit again, so to 1897, we had Thomson. Now, Thomson really was a remarkable man, and for several reasons. He contributed a lot to the understanding of the atom, but it wasn't just his contributions. He had a whole bunch of his students went on to win Nobel Prizes for their contribution to atomic theory or other areas of science. So Thomson basically investigated the particles that were released from a cathode ray tube. So cathode ray tube is basically an electron gun, although they didn't realize that at the time. So he found that the particles released were about 1,000 times smaller than an atom, and in particular than a hydrogen atom, the smallest known atom, and that they were negatively charged. And so he found out basically that there were these tiny particles, smaller than an atom, that were negatively charged, and they were later named electrons. Now how he did this is basically from the electron gun, they were being fired out, and he passed them through two electric plates, and he found that they always curved towards the positive plate, but that they also went further than you would expect if they were an atom. If they were bigger, if the particles were larger, they should curve earlier towards the positive plate. Now you don't need to know that kind of detail. Basically the key thing here is the heading I've got there. Thomson essentially discovered the electron, that there were negative components to the atom, and you need to know the model that he proposed, which is essentially this one down the bottom, the plum pudding model. So essentially what he was saying is because he discovered these negative bits, he knew there must be some positive stuff in there somewhere too. Because if it was all just negative, if there was just these negative particles, negative would repel other negative particles, like repels like. So if it was just these negative parts in there, they would all repel each other and they'd just spread apart and go flying everywhere. So he knew there must be some positive stuff in the atom somewhere holding it together. So he proposed that the atom was made out of like a pudding that was a positive material, and that it had these negative particles trapped within that positive material. So very much like raisins in a plum pudding, he said the electrons were kind of scattered or dotted within some sort of positive material, and that's what stopped them from repelling each other and them all just flying apart. So that was Thomson's plum pudding model. Prior to him, there were some theories that the atom might be made out of smaller parts, but essentially people thought hydrogen was as small as it gets, and that the other atoms might just be a combination of hydrogen atoms pieced together. And Thomson really sort of went well beyond those ideas, that it wasn't just even hydrogen was made out of smaller parts again. So it was really Thomson who revealed that idea that these atoms were as small as it gets was actually incorrect, that there were even smaller parts that the atoms themselves are made out of. Like I said, a very remarkable man, and not only because of his contribution, but must have been a remarkable teacher, because 7 of his students, including his own son, went on to win Nobel Prizes themselves. So next we have Rutherford, very special and dear to our hearts as New Zealanders. Rutherford was a New Zealander, although he did most of his work in England, but definitely we still lay claim to him as one of our most famous and revered scientists. So Rutherford was actually a student of Thomson. He took over the work from Thomson and took over the laboratory when Thomson retired from that position. And Rutherford made a couple of key discoveries. So first he discovered that an atom is mostly empty space with a positively charged nucleus that's orbited by electrons. So basically discovered that an atom is mostly empty space with electrons flying around it. Now I'm going to talk a little bit about how he discovered that, but again, for each of these things, you're really just, for your assessments, you're really just expected to give a brief description of the model and maybe a quick sketch of what that model looks like, and possibly, or we would kind of expect the name of the person who came up with that model. So this is essentially what Rutherford did. He it was known, or there were theories at the time, that radioactive materials were atoms that were breaking down. So in this box here, he had a radioactive material that was shooting out essentially small fragments of an atom, small parts of an atom. And he shot it at a layer of gold that was essentially so thin it was only a few atoms thick. And what happened is 99% of the time, the particles from this radioactive source would just shoot straight through, and you would see that as little spots on essentially like an X-ray film, where it would fluoresce or light up when those particles hit that film. But what was kind of intriguing to Rutherford, or what really sort of blew his mind, was the fact that occasionally the particles would get scattered off to the side or even bounce back. And there's a famous quote from Rutherford where he basically says that it was like taking a gun and shooting tissue paper and having the bullet bounce back at you. He really wasn't expecting any of these particles to bounce back. And the reason he wasn't expecting them to bounce back is this top one is basically Thomson's plum pudding model. If an atom was like this, a bunch of positive stuff with little negative bits in it, you'd expect the particles to go straight through it every time. If we shoot a plum pudding with a gun, the bullet's just going to go through it. It doesn't matter where we shoot the pudding, it's going to go through every time. However, Rutherford's particles, every so often, one got scattered off to the side or one bounced back. And what he realized from that was that the atom must have some really dense core. And so this is Rutherford's model just down here, with a really dense core, some sort of spot in the middle, where if the particles happen to collide with that dense core, they would either bounce off sideways or bounce back. Whereas most of the time they didn't hit this core, and so they missed it and they went straight through. And that's really how we figured out that model of the atom. So this is Rutherford's essentially solar system model. The nucleus in the middle here is a dense core, and if the particles were to collide with that, they would bounce back or go off sideways. And the electrons were much smaller and orbiting or flying around the outside of the nucleus, and most of the time his particles would just go straight through the empty space. So Rutherford also theorized, so he realized that these electrons were the negative bits flying around the outside, and that the nucleus must contain the positive charge, the protons. But he already theorized that there must be something else in there holding those positive charges together, because otherwise they would repel each other and they would go flying apart. And so he theorized that the electrons were flying around the outside, the protons were in a core in the middle, but that there must be something which essentially became known as neutrons that held those protons in place, although he had no way at that point of proving the existence of neutrons. Okay, so that's what I've put here. He also came up with the theory of the neutron, essentially just as the glue that holds the protons together. If the protons are all positive, like repels like. We often say opposites attract. So if like repels like, those protons would repel each other. So Rutherford did really contribute a lot to our understanding of the atom. Anyway, after that, Bohr in 1913, so these are all only a few years apart, another student of Thomson actually came up with the idea that the electrons weren't just distributed randomly around the atom. So basically, Bohr came up with a theory that atoms consisted of a positive nucleus with electrons in certain orbits or energy levels or or shells. So we use those terms basically to mean the same thing. So he came up with the idea that the electrons are organized into shells or layers or energy levels around the nucleus, that some were closer to the nucleus and that some were further away from the nucleus. And we'll actually look at, so this is a shell model or a Bohr diagram, and we're actually going to look at those a little bit later and look at how to actually draw those diagrams based on the number of electrons in an atom. So there's a pattern to how they're arranged into those shells. Lastly, we've got Chadwick in 1932. So he finally discovered the neutron. That Rutherford had come up with the idea that there must be something holding the protons in place. So this basically, the discovery of the neutron also explained why an atom was heavier than it would be if essentially it only contained protons and electrons. So the neutrons had mass; they contributed to the mass or the weight of the atom. But they didn't have any charge. They're not positive or negative. So you can see here his model here, that this is the nucleus. I've left out the electrons here, but that some of the particles are positive, those are the protons, and that these neutrons, which had no charge, were neutral, still contributed to the mass of the atom, but weren't charged, and basically acted like the glue that holds those protons together, because they would otherwise repel each other. So that gives us essentially our final model of the atom, which really is that nucleus of protons and neutrons, with electrons organized into shells much further apart. The atom is mainly empty space. And yeah, these are really the scientists who contributed to that model. So again, going through it, what are you expected to know for your test? Basically, Democritus, the idea that there might be some smallest unit or part that isn't divisible, and just a circle as your model. Dalton, through experimentation of pure substances, finding evidence that elements around us are probably composed of these atoms, and that there are different types of atoms that just have a different size or mass. So again, just pictured the world made up of like billiard balls, is what was said, like small balls. Followed by Thomson, who discovered the electron parts. So his model is a plum pudding, which you can just draw as a circle or a patch full of negative sort of dots just all over the place. So he discovered the electron, a much smaller, negatively charged part of the atom, and so he assumed that there must be some positive material acting like a glue to hold those negative bits together. Rutherford came up with the solar system model, so you could draw a little solar system sort of style picture, and again, he basically discovered that the atom is mainly empty space, that the electrons are around the outside, and that the protons, the positive parts, are in the core, in the nucleus, and also came up with the idea of the neutron. Bohr just basically draw a shell diagram here. So the atom, it's got its core, its nucleus, and the electrons around that are arranged into shells. So you could easily draw that. And lastly, Chadwick was the one who discovered the nucleus, and that essentially just proved that there was these glue, basically this glue holding the protons together, that they contributed to the mass of the atom. That's why the atoms seem to be heavier than we would expect them to be if they were just made out of protons and electrons. That they'd be heavier than if they were just made out of protons and electrons. And he basically provided evidence for the neutron. So that's basically it, guys. I really recommend maybe going through this video with your flashcards or referring to that table, and just familiarize yourself to the point where you could give me in a test the name of the person who made that discovery or came up with that model, a description of their model, literally just one sentence, the most key idea. So I've often put that in slightly larger font here. And just a quick sketch, like kind of illustrating what the model was that they had developed. So okay guys, I hope that really helps. You can go through that again, like I said, run through that, make sure you can give me the name, a one-line description, and a sketch of the model that those scientists came up with. Awesome.